So with that, let me give you Peter Thorne.
John, thank you. Thank you very much, Joel, and I'm delighted to hear that the bluff about the English accent is still working after all these years. That's marvellous. Now, when Brad told me about this session, he said that we might have a few problems just keeping the picture on the screen. But he said, try and make it interactive. And he said, and stick to the facts. So he knows me. So I thought, okay, interactive, stick to the facts. Let's have some facts. And with or without my first slide, is there anyone here who knows anything about baseball? Could you tell me, so you know, I'm a Brit, I know nothing about baseball, the most famous baseball player ever? Babe Ruth, spot on. Why is he famous? Well, he's famous for all sorts of reasons. The reason I know is that he set the record for the number of home runs in 1927. 60 home runs. Now, continuing this theme, do you know when that record was broken? 1961, and Roger Maris with... Yeah, and how many home runs? 61. And I thought... When I saw that, I thought it was brilliant. You know, it's the way you can remember it. 1961, 61 home runs. And, you know, great in a trivia competition. So let's catch up the slides here. 61, Roger Maris. 1998. Yeah, we're getting there. Okay. 70 runs. Big increment. It was Mark Maguire. And then, of course, 2001's Barry Bonds? Oh, okay. I know nothing about this. 73 home runs. Now, if I was in the audience, if I was sitting where you are, at this moment there would be one burning question in my mind. So what? So let me point this out to you. Babe Ruth, 1927. 2 years later, big financial problems. Roger Maris, 1961. 2 years later, big problems of conflict. Mark Maguire, 1998. 2 years later, NASDAQ peaked and crashed. Barry Bonds, 2 years later, conflict. 4 data points, a pattern emerging, finance, conflict, finance, conflict. What happened in 2006? Baseball let us down. Ryan Howard with 56. You know, not enough to predict the credit crunch in 2008. So all of this is really just a very long way round of giving one health warning about the sorts of things that I'm going to be talking about, the facts, the numbers, what's going on in the market. And the point here, I think, is one that everyone here is probably very aware of, which is that a correlation, you know, may be very strong, but doesn't actually prove anything about the cause of a particular phenomena. And, you know, there are other examples of that. So that picture of the stork is to remind me about a city in Denmark, Aarhus in Denmark, where it is reliably established that storks nest on the houses where there are the most babies. Absolutely, completely reliably. So there's an explanation for that, isn't there? And that is that the storks bring the babies and stay. It's the obvious place to nest. And there's another explanation, which is if there are babies in the house, it's warmer, and that's where storks like to be. That picture of a rain cloud is something from my childhood years when I was playing around with astronomy. At that time, believe it or not, I, as a kid playing around with astronomy in the UK, bumped into the Idaho Potato Farmers Astronomy Association. Now, how could that possibly be? The reason was that for a period of 5 years in Idaho, rainfall had correlated perfectly with the phases of Venus. This had triggered interest in astronomy in the farmers, and they had created an astronomy association. So, correlation is interesting, but it can steer you in the wrong direction. My second health warning is about segmentation. And the example here is the Alien Cosmetics Company, who decided to launch their cosmetics products on Earth, and they chose Europe as their entry point. Okay, so they went through the usual stuff, abductions, you know, you get it over here as well, don't you? And they did their research. But when they launched their products, they absolutely bombed. Nobody was the slightest bit interested in their products. And so they got in the research team and said, you know, now what's happened? You know, you're usually so good on all these other planets. You've found us the right makeup for, and the right products for the population. And they then quizzed the chief scientist of the research team. And they finally found the point where he'd gone wrong. Because in all the analysis that they'd done of these Europeans that they'd abducted and they'd then scanned and done all of their tests, they'd come to one conclusion, which was that the average European has got one ovary and one testicle. And they were right to perhaps 5 or 6 significant figures. However, they had simply not understood a kind of segmentation in the market that is obvious to all of us. So no surprise that their products bombed. So, with those 2 health warnings, there are 4 things I want to talk about. An introduction, talk about the technical application software market, something about industry sectors, and a few observations at the end. So, introduction to Kambashi. What do? We try to understand the use of IT in industry. And you can see the 4 sort of focus points, I suppose, on the left: business reasons, the technology, the way the market works, and the impact of the deployment of products. And then on the right-hand side, you can see, you know, the usual stuff that analyst consulting firms do. But the part that I want to concentrate on today is the market observatory. This is the work that we do on maintaining quantitative models of the market. So we gather a lot of data and put it together into models which try to explain where these numbers are arising from. And that's going to be the focus for the rest of my talk. So, technical applications. This is the segment we're going to look at. So I thought I'd better explain, you know, briefly what it is. So we've got a longer definition of this segment, but the short version is that technical applications support the tasks using engineering, scientific, and creative knowledge. So it includes all the stuff that we deal with in engineering software, PLM, all the computer-aided design, manufacturing, engineering technologies, all of the AEC, building information stuff, GIS, if anyone uses that term anymore, or geospatial, I suppose, imaging, visualization, all of that stuff. But it excludes commercial applications, so no ERP, no supply chain, none of that stuff. It excludes the plant floor apps. That's something we also look at, but it's not in this technical applications category. And it excludes all of the office and the productivity applications. We look at these things in 4 ways. So a kind of product view, looking at what vendors are doing, which is a pretty well understood way of looking at the market. You know, the vendors, the public companies in particular, publish a lot of information about what they do, and that's an important source of data. We also look at it from the point of view of countries, so what's going on at a national level. We look at industry sectors, and we look at employment as well. So I think the way to understand this is that somewhere at the center there is this truth about what's going on. You know, this is the technical applications market. Now, it's very hard to get at that truth. So what we do is look at it through 4 lenses, if you like, that distort things in slightly different ways. But what we particularly try to do is play a kind of giant Sudoku on this whole set of data and models, because it's all got to add up to the totals. And so what that means is we find the linkages across between industries, between country economies. We make assumptions about the way that industry sectors probably behave in the same way in all of the developed economies, for example. We interpret what companies report in their financial reports and map that to the models as they must be to make the totals add up. So what we end up doing, in fact, is aggregating many sources of data. And in a sense, our models are the models that provide a best fit for this large number of sources. And those sources range from, well, going around this picture, the national statistics, all of the websites around the world where governments publish what they think is going on in their country, IMF, OECD, World Bank, all of those sorts of economic forecasts and measurements and reports, of which there are many sources, the European sources, commercial sources, all of the company filings, and then all of the employment stuff. And we try to do this in a way where we can compare between countries. So we've normalized on the so-called ISIC codes, the international SIC codes, as being the way that industry is structured. And we use the ILO, the International Labour Organization, to help define what the employment categories are in order to be able to make this consistent across the world. So let's explore the numbers. And I thought I could show a lot of spreadsheets at this point. And then I remembered a point when I was actually presenting results of a project. And I had to say to the client, I've got 48,000 numbers in my spreadsheet here. Shall we have a look, or would you just prefer the headlines? And the client, not surprisingly, said, well, just show me the headlines. So instead of the headlines, what I thought we would try today is a new way of looking at this, or new for us anyway, which is to use Google Earth, which I just have to tell it that we're not connected to the internet, and that's fine. And what I'm going to do is load data from our observatories in order to be able to see it. Now, in this case, what I'm loading is growth figures calculated in operational currency. Okay? So what this does is take a percentage figure for growth calculated in the operational currency of the country. Now, operational currency is often local currency, but there are some countries which don't use their own currencies for business transactions of our sort of software and systems. So we use those currencies for our calculations. We choose the operational currency for our calculations. Essentially, those percentages on this diagram are then scaled from the largest number, which gets bright red, to the down to 0, which is grey. And all of the positives are the warm colours. And then if there are any negatives, the largest negative is a bright blue, and then the sort of pale blues and greens are the small negative numbers. And you can see on here, we actually cover the entire world with our figures. But I haven't included the regions which are covered as aggregated regions. So, for example, we've got Maghreb, which is the 5 countries up here, Libya, Algeria, Tunisia, Morocco, and Mauritania. We have sub-Saharan Africa, which is everything from Angola to Zaire down here. And we've got all the stans over here. And although we have aggregated figures for those, I've only included the figures for which we've got specific country information. So, what you can see is, well, if we look at this, look at APAC, you can basically see that we've got, generally warm colours, except for South Korea and Thailand. So Thailand looks at, a fairly negative number, and South Korea is somewhere in the middle. So if I click on South Korea, now I don't know if that's readable to you, but let me explain what's on there, just in case not. All of these pop-ups come up showing the largest positive as number 1, and the sort of smallest, the negative, the most substantially negative as at the bottom line here. So we have the top line and the bottom line is always the same. And then the country I've clicked on comes up in the middle. So here in this data set, Egypt was the largest growth in this year, 2007, at 36.5% in technical applications for growth during the year. Thailand was the worst performer, minus 6.6% growth. And the one I clicked on, South Korea, was actually showing minus 0.9% growth. So I must also point out and make reference to David Trees, who is the producer of this capability that he calls the KML Factbook, that helps structure data for presentation in Google Earth, and my thanks to him for that. I would also point out this, we also get the title of the data set, so we're looking at technical applications growth, in this case in operational currency, and the year, 2007, which is a clue that actually we've got other years loaded in there as well. So if I now look at the Americas, so we're looking at 2007, but if I just press the play button here, then we'll scroll through the years through to 2013. So obviously we're moving from historic stuff to forecasts, which are forecasts from our models. And on the 1st of January for each year, we get a display of that year's growth. So we've moved on to 2009, a few cool colors. 2010, the growth is coming back. 2011, and up to 2013. So, on our models, here's 2013, and if I just spin the world around a bit, you'll see it's a happy place. It's all warm colours. Everything's growing. There don't seem to be any blues or greens or anything nasty like that. Which, of course, reminds me of the words of the Nobel Prize-winning economist, John Kenneth Galbraith. I don't know if you know of these particular words, but when he was describing forecasting, and specifically economic forecasting, and I have to admit there is some economic forecasting built into these figures. We use economic forecasts to understand how industries are going to behave in order to make forecasts about what the technical applications market will be. But John Kenneth Galbraith, who knows far more about these things, he died, but he knew far more about these things than I ever will, said, as he understood it, the purpose of economic forecasting was to make astrology look respectable. So, a warning from the master of that. But if I move back to South America, there was just something that I wanted to point out here. So we're working in operational currency, and if I just grab the slider and move up and down the years, you'll see that Brazil and Peru here both stay positive throughout this entire period. So, okay, they were affected by the credit crunch, but they still maintained positive growth in their operational currencies. Now, if I switch data sets, so I have to delete all of these, so delete all of those. Yes, I do want to delete them. And open a new set. So what I should go to is the same data, but this time expressed in US dollars. So it's quite, there is quite a difference here, and you do have to be a little bit careful when you're thinking about US dollar growth figures, because remember you've got multiple years of currency conversion factors to get a growth. You've got the previous year and the current year in order to judge what that growth figure is. But the thing that I wanted to point out was that if we go back to Brazil and Peru and just scan through, then measured in dollar terms, poor Brazil in 2009 actually contracted. The market for technical applications measured in dollars contracted, which means that there's going to be a kind of interesting conversation between, the country manager in Brazil and the guy in headquarters who's trying to aggregate all of the numbers in dollars, when they are either looking at the results or they are planning the investment for the market for the next year. It is quite easy for these people to be talking at cross purposes if they don't appreciate the effects that those currency differences can have. So to get an idea of what that might actually mean, what I did was to just take this data and look for cases where that difference had, it makes a difference almost everywhere in terms of the size of growth or the size of a decline. But I looked for cases where the difference was enough to be the difference between growth and decline. So in one currency, it was one thing. In dollars, it was the other thing. So the calculation was, let's have a look, it's in this data set here. And now, in this case, most countries are zero because it's the same. The results were the same. But the countries that are highlighted show the sign of the growth as measured in US dollars. Okay, so if it's red, that means that the US dollar result or growth was positive, and yet the operational currency was negative. And if you go around the world, I mean, if we look at Europe a little bit, I guess I could help to make it a little bit bigger like that. And then just scan through the years, you can see that in 2008, the dollar results were tending to overstate what was going on in Europe for the operational guys. Come 2009, back to the same everywhere except Poland. So where Poland had been one thing one year, it was the other thing the other. So quite what was happening with the zloty that time, I'm not too sure. If we go around the world, over to Asia. This data set only goes up to 2010 because we're not in the business of forecasting what currency exchange rates are. If we were any good at that, we wouldn't be doing this. So, if I go to 2007, we have South Korea, which was where sitting in headquarters in the US, you might be saying, come on guys, this market is growing. Actually, sitting in South Korea, that was not what you were seeing. And if we scan through, just some variation year by year. So I think it's a point that is well known, but currencies can indeed make a difference. So if you are ever having a conversation about growth rates, make sure you know what currency you're discussing. So I mentioned the employment observatory, and I thought one analysis that was interesting in this was to look at the actual spend per engineer. Now, this is using a kind of 3D representation where the height of the block represents the number of dollars per engineer that is being spent on technical applications in that country. And I've only done this for 1 year because I think the variations across years, were at the limit of anything reliable, mainly because of the employment data. In the developed economies, I think that the data is reliable. The way that engineers are classified is fairly consistent and can be normalized. Away from those places, really getting lots of different ways of counting engineers. And there certainly are countries where if you ever pick up an implement like a spade or, that can have any effect on the real world, you get counted as an engineer. And I've got to believe that is part of the reason why the Ukraine here is quite so low. And I know in this analysis, it is actually the lowest, just with $3 per engineer being spent, which means either the price of software there is very low, or there's a lot of piracy, or they count too many people as engineers. So you've got to be careful with this data. But going to the developed economies, I think it's much more reliable. So I think it's no surprise to anyone in the business that Japan comes out with, this, you can just look at the profile, it's way ahead in terms of its spend per engineer, coming out at $411. And I think there's a reason for that, one of which is that the price of software in Japan is much higher, and the other of which is they are very careful about their definition of professional engineers. If you look at the US and Europe, getting a lot of kind of similar-ish sorts of numbers. So the US there is coming out at 177. This representation, of course, always to my eye, seems to overstate Hawaii as part of the US, which gets this, this little landmass with a lot going on there apparently. And in Europe, well, and I don't have an explanation for this, but Norway comes out with the highest number at 306. It sort of feels as if it could be in the Scandinavian character to be like that. And then the others, pretty much as you expect, Germany, France, the UK, with Italy, coming in, sort of following close behind, I suppose, and Spain a bit behind that. And then over in Asia Pacific, I suppose it is worth pointing out these small columns, these small but tall columns, which again, no surprise, with Singapore here, and also Hong Kong, that producing these relatively high spends per engineer. Sorry, I clicked on China. Bit hard to aim for Hong Kong. I'm afraid the software engineers aren't quite up to mechanical CAD standards for being able to select 3D objects. You have to aim so that you actually get the underlying landmass, it seems. So, what I want to do is just delete that data set. Get rid of that. Yes. Put that away, and then I can go back to my slides. So that was a quick exploration of the numbers. And what I wanted to then look at was to say, well, is there a noticeable impact of the crunch from which we can learn about the way that different countries behave? Now, apologies for the colours and the sort of thinness of the line of these charts. I've actually selected 3 of the 65 countries just to put on a chart here. The critical thing is that each of these charts shows, again using local currencies, technical applications growth, which we've already looked at, the GDP growth in local currencies, and then another important factor, which is the investment growth. So that's particularly important when you're looking at production and factory automation and that side of the business. And I looked at that and thought, okay, what is going to be the best way to try and do a triage on these 65 countries and try and find groupings that make sense? And my conclusion was that the most useful grouping was to find graphs that looked about the same, that where these curves looked around the same shape, because they're all actually a little bit different. And I toyed with the idea of some kind of great algorithm which looked for similar shapes of curved, but then I'm afraid I reverted to the Mark I eyeball as the way of doing this. And ended up coming up with, down the side there, the 3 groups where those 65 charts of tech apps, GDP, and investment growth look approximately the same shape going through the credit crunch. And there's a group at the top where they achieved some growth in 2009. And, it includes the ones we all talk about, China and India. It also includes some smaller economies, Australia, Kenya, Nigeria, and Vietnam. And then not so far behind those were a set of countries which only showed a really quite small decline during 2009. And that's Egypt, South America, except for Chile and Venezuela, the Philippines, Singapore, and South Africa. And then, the large decline, it was the developed economies, but also Mexico, Russia, Middle East, and Taiwan. And if I then kind of looked at the world and said, well, is there a geographic region which has performed the best? There's no doubt it was Asia Pacific, with the exception of Japan, which seemed to be the least affected by the credit crunch. And, what reason could there be for that? And I think the answer is, and, this is, I suppose, speculation, but, it's something about those economies. A lower intensity of financial services, more added value added from production, and lower cost of workforce. So let's move on and look a little bit at industry sectors. Now, in order to look at industry sectors, I've actually selected just 2 countries, which I think are interesting examples. And what I've done here is take figures from the observatory, from the Cambashi observatories. I've aggregated all the industries together into their top-level headings, the top 13 in the ISIC coding system. And you can see the results there. Now, of course, manufacturing, this is a big sector. I mean, that's got all of the manufacturing industries in there. But one thing that I must point out, which is a problem with the colours and indeed the ISIC coding here, is you probably look down and think, oh yes, well that next one must be electricity, gas and water supply. That would be a natural assumption. In fact, it's not. The next one down is the real estate line. And, that's got to be just bizarre until you understand the ISIC coding system, because it turns out that all of engineering services, so all of the people who design and build factories and process plants, end up in the real estate sector in this coding system. So it's a slightly curious, and of course, in reality, if we were actually doing some kind of a study in these numbers, we'd have to pull out those lower-level codes and probably separate them into, the fractions that were electricity or water or gas, because I think most people interested in that market want all of those things put together to see the spend of all the engineering companies working on electricity systems, for example. But anyway, that's the shape of the curve. And the other country that I pulled out was Germany. And if I just flick between those, I think there's a very clear and interesting difference. One is an emerging economy, where the crunch has been a bit of a setback, but then growth in manufacturing continues. The other is an established and developed European economy, where the credit crunch was a big setback, but then, there seems to be a line of a new normal that has set in. And that sort of return to growth seems to be, well, much more muted, I suppose, is the best way to put it. Sorry, that was good. Yes, there is a difference in the scale here. In fact, the scales are different. They're euros and dollars, although not so different just at the moment. And you can see that on the left-hand scale, manufacturing drops from 500 to 400. Go back to Brazil, and it dropped from 90 to 80. So, yeah, significantly different size of economies. So, I suppose that gives rise to this question. Are we, in some sense, approaching or at a tipping point? What are the changes really going to bring? And if you talk to economists, they will point to 1945 as the time when the US really emerged as the global economic powerhouse. I mean, it obviously had been there before that, but up until that time, Europe had been able to make a show of being, at about the same level. And after, from 1945, that was really not the situation. And the question arises, well, actually, has the financial crisis been sufficient to create an opportunity for someone else to step in and kind of just give the US a bit of a shoulder as the leading economy in the world? And, the place to look is clearly the BRIC, the other emerging nations. And Brazil, Russia, India, China is a very interesting group. I mean, between 2000 and 2008, they actually provided half of world growth. So clearly, if there was going to be some kind of a change in the world order, that's the place to look for where it's going to come from. But, as I interpret it, and as I read the interpretations of people who make more of a business of this megatrend type forecasting, they point to the fact that these emerging economies are not yet balanced in the way that the US economy is balanced. So the US has this diverse mix, and in particular has this combination of a consumer-based economy and a production-based economy, as well as financial services. It's all there in the US economy. And that's simply not true in these emerging economies. So if you look at Brazil, what impact does it have on the world stage? And it's mainly to do with its agricultural exports. Look at Russia, what does it do? Well, you know, it's got huge, just minerals and materials, and oil and gas dominate what it appears to do on a world stage. It sells oil and gas. India is well known for software and services, and that's the focus. That's where it has the success. That's where it influences the world. China, of course, is the just a huge economy, a huge growth economy of this group. And it has the size, it has the world trade that's going on, but it seems to be focusing entirely on production. It is not, so even its stimulus package for to handle the financial crisis concentrated on fixed investment, you know, more factories, more capability to do trade, rather than trying to stimulate, for example, consumers to create the kind of balanced economy that you find in the US. So I think the message is that no, the US's position is safe at the moment, and you know, and just to back that up, I wanted to have another look at some of the numbers. So if I just go back, if I can find, can anyone see a cursor? No? Okay. Slight technical hitch. Well, I can see the cursor. There it is. But it doesn't seem to want to move from right. So I'm back to touchpad here. And I just wanted to show you one more data set. And this is the data set which shows the total of end-user expenditure on technical applications. And of course, this has to be measured in US dollars to make it comparable around the world. So what I'm looking for is US dollars end-user expenditure, and it's shown as a share. So this is taking the total end-user expenditure in the world, dividing up into 100%, and then sharing it out. So let's look at that. Click on open. And that's where you get an impression of the relative sizes of the markets for tech app software around the world. The US is the leading market with about 28% of the world market. And the view that I think of this, that I think is interesting on this, you have to kind of set it up, so bear with me for just a moment. And this is really difficult with a touchpad because I've got to hit Control and the left button all at the same time. And then I just need to scroll this over a little bit more. And what I'm trying to see, I want the emerging economies just over the horizon. I want China and India just over the horizon, and I want to be able to see Europe. And then I want to run through from 2007 to 2013. And what you'll see is that the US stays pretty steady in terms of market share. And China, in particular, grows its market share. And where does that come from? On this model, it appears to come from Europe. So even though, actually, as I said earlier, overall, by the end of this period, it's a happy place, everyone's growing, so the actual total volumes of business aren't declining. They may well be growing. In terms of share of the world market, what this model shows is China and India taking share mainly from Europe, and the US maintaining its share. In fact, it varies around between about 28 and 30% through that period. So, with that, I think I just have just one slide of observations. Why does all this stuff exist? It exists mainly for manufacturers and companies around manufacturing that support manufacturing. So what is going on in manufacturing is critical to the health of the technical applications market. The old must-do list is there and will remain there. Cost control, quality, being able to schedule the stuff that you do, fast time to market with innovative products, good asset utilization, being able to operate and source components and source materials and so on globally and sell globally. But that now is the old list. There's a new list as well. The must-do list has just got longer. There is global competition. I saw an example of a Chinese car manufacturer that I had never heard of that had been operating just in 3 countries in Asia Pacific. They announced their expansion program, going to South America, I think it was. And these are new competitors, and probably that is a threat for manufacturers. I have to say, at a strategic level, it's got to be one of the thoughts for tech apps vendors. There are strong software vendor companies in China. They have substantial home markets. And I know this when I got a first-hand report from somebody at Kambashi who had been on holiday, just going up the Yangtze River. And lo and behold, they stopped off in a town in the middle of, a town that you've never heard of, in the middle of nowhere. There was a software shop in the middle of that town. It had software that you would recognize, so yes, there were copies of AutoCAD, there was Adobe stuff there as well. And there was an ERP system called Happy User. And you think, well, that's interesting in all sorts of ways. Number one, there is the locally produced ERP system available in a shop, in a town, in the middle of nowhere in China. But secondly, doesn't that just show you a different approach to what software is for? What is the purpose of that software? It wasn't for rapid scheduling. It wasn't for, time to market. It was for Happy User. That was in the title. Anyway, back to manufacturers. What do manufacturers have to do? Deal with new competitors, share customers' projects, be part of the project, share the risk, be able to provide responsive customization, handle changes, all of these things, be able to prove compliance. And one that I think is going to change the way that manufacturers behave, there are more and more real-time parameters. So I heard the story the other day of a US manufacturer who some years ago used to write business plans based on a single value for the price of electric power. At the beginning of the year, they said, the management team said, what's electricity going to cost us this year? And they came up with a number. That same manufacturer has now, on a peak day, they handled 48 changes in the price of power that they were using during a single day. And I'm sure you've heard all of the stories about manufacturers who build generating capacity. They can sell it to the grid. And these markets operate, and you decide whether to switch the generators on in order to run your own production machines, whether to buy power to run your production machines, whether to switch your production machines off and sell power to the grid. All depends on the price. And I'm sure you've also all heard about the curious fact that all of these generating systems, when the utilities phone up and say, could you help, they're all broken unless the price of power is at the absolute top level. It's just one of those things. It just seems to happen. So, more challenges for manufacturers. But if you think about the technical applications industry, that's got to be a good thing. Each challenge for a manufacturer actually drives the value of engineering software to that manufacturer. There is more of a need for the capability to handle the difficulties, if you see what I mean. Now, I put one line there, and it is just one line, my personal thought on where those opportunities are. And I do believe there are opportunities, which I've summarized into two types. Data flow on the one side, which is just the way that engineering data is used around organizations and networks. You know, we have just scratched the surface of the changes that manufacturers might make as they're able to use that to get data around their organizations more effectively. And the one on the right, requirements, functions, solutions, what I'm really thinking about is individual and team productivity. And if you think about the history of engineering apps, there's been a huge amount put into the solutions side, i.e., how does a designer actually create the solution? How does a manufacturing engineer create, you know, the manufacturing setup, the programming, the programs that are needed for the production machines? There's been huge effort on that side. And I think where there's huge opportunity is going back upstream to the kind of systems engineering, the requirements. Requirements turn into functions. Functions can be implemented in all sorts of different technologies, which are the different solutions. And as manufacturers begin to be able to allow engineers, designers to move quickly between these views and have this sort of complete fluency to be able to find out from a solution what was the original requirement that generated that. I think there's going to be a whole new level of productivity, of opportunity for collaboration and so on. So, a difficult future, but for the engineering software industry, for the technical applications industry, I think a future with a lot of opportunity. And that's it. Thank you for listening. So we have some time. So we have, I think, a couple of minutes for a couple of questions.
Peter, a quick question. Was it about $300 per engineer in the U.S.? Right?
It was less, wasn't it? I think it was 170, yeah.
And how many engineers did they show in the U.S.?
How many?
How many? Yeah, I mean, it seems like there must be a far larger number of engineers than normally credits.
Yes, I mean, that's I think the question was how many engineers in the US?
Well, for example, if we had 1 million engineers, that'd be 176 million.
Oh, absolutely right, yes. There are, the US is the largest market in the world, okay? By itself, 28% of the technical applications market.
But I'm thinking like somehow data has having like 30 million engineers.
I'm sorry, I don't have the numbers in my head. I could dive into some spreadsheets, but maybe we ought to do that offline. But you're absolutely right. Yeah, there are more engineers. They're spending. The average spend is, you know, in the middle to high end of the world range, giving this very large spend. But it's not at the level of Japan. So if you're a real optimist, about the business, you could say that there's room in the US market to go from 177 per engineer to 411 in Japan. Will that be the effect as the US workforce reaches the age profile of the Japanese workforce? Oh, only two components. The end user expenditure, sorry, the question was, what were the components that produced that figure of $411 per engineer in Japan and 177 in the US? Very simple. There are only two components. One is the total end user expenditure on technical application software. The other is the number of professional engineers, which is a list of maybe 15, something like 15 to 20 categories in the labor statistics, the employment statistics figures that we have. So it's adding up all the people who are reported by their governments to be professional engineers and saying that's the pool of professional engineers in the country, and then dividing the total expenditure by that number of engineers gives a number of dollars per engineer. I'm sorry.
What other things are being purchased or consumed by people in Japan that aren't necessarily being consumed by people here in the States? That drives economic growth.
In the case of Japan, I think it's dominated by the price of software, in fact. I think they're consuming about the same number of units of software, they just pay more for it. Yep. Not as part of... No, we've only done... sorry, I'll just repeat the question. Thank you. Sorry, I'm forgetting this each time. The question was, have we done any work on the trend of unit prices? And the answer is not as part of our observatory information, that I can talk about. We've done a lot of that on proprietary studies, with individual clients. But no, there's nothing that I can talk about. Any more questions? Yes, please. The question is the reports about the numbers of engineering graduates in China and, just the huge numbers, in fact, of graduates who come out of university as well-trained engineers in China. In terms of these figures, yes, that as a source, what it means is that there are going to be higher numbers of engineers in China. Sorry, that's a bit of an obvious statement. It means in terms of this calculation, the spend per engineer will seem to be relatively low. In my mind, the question will be how many of those people are doing comparable jobs to people in other economies. And this is where you've got to be, where the health warnings that I gave at the beginning all apply. What is the segmentation? For example, I remember when we were looking at Japan in civil engineering and looking at structural engineers, there was a curiously low number of structural engineers in Japan. Why was that? It turns out that in Japan there is a history and a culture that general engineers do all of that work. So you get, in these columns of different types of engineers that we aggregate, that I put together to make my total of professional engineers, if you look at something like structural engineers, in Japan you get these low numbers, and that's misleading. It's wrong, because it's not that they don't do structural engineering, it's just that general purpose engineers do this work for you. So, yeah, as you dig into these numbers, I'm afraid my answers are increasingly, as you try to get to the detail, yeah, you've got to do a lot of detail to extract more information. Yeah. They account for pirated software in the sense that we only count the revenue that people pay for the software. So where there is pirated software, that doesn't appear in those end-user expenditure figures. And yes, there is pirated software, and not for these figures, no. No. I mean, yes, we study pirated software and, what the rates are and so on in order to try and do the... Sorry, when I say no, in terms of the market models, we do. So when we're matching up employment to country expenditure, we make an allowance for the pirated software to as we try to make those things fit together. Yeah. Do we have data on the price of software in the US versus the price of software in Europe, of the same software? Yes, but it's not something that we put into our observatories. Most times, in the UK anyway, we find it incredibly easy. We say, well, you take the dollar price, and that's what the price will be in pounds. And it doesn't matter what the exchange rate is. That's so at the moment, you know, the effective price is 1.5 times the same software in the States.
Why are the customers angry with that model?
Sorry, can you say that again?
The customers are angry with that model. You don't like it.
So are the customers angry with that model?
Because the software is saying
Yes and no. Most people, well, there's a lot of software, a lot of technical applications that are bought as part of projects. So actually, although people do become, you know, a little bit aware of the unit price, it may not be the dominant factor. There are also global projects where actually the negotiation is done, you know, in Europe and the US for global distribution. And in that case, the pricing is special. There certainly is commodity software where, yes, I think people do find price differences around the world frustrating. But I think the answer to that is, well, you know, go and buy it in another country and bring it home with you in your suitcase. Well, only if you get found out, you know. Yeah, sorry, I was being flippant. You're exactly right. It's So why? So that's the model that you adopt. Yeah. But you would say that you think customers are unhappy with that model. So there's a chance, you know, break the model and find some happy customers. Is that not the opportunity? I mean, if customers are unhappy, does that not create, you know, the opportunity for you to do something differently? Yeah, they complain, but that's how it is. And yeah, at the end of the day, Europeans shrug their shoulders, I think.
That's why software companies make the customers unhappy to generate opportunity.
Now there is a whole new theory of business. But in that case, I would point to the Chinese and the title of that ERP system, Happy User. And, you know, take that line of business and you may be under a longer term threat. Okay, I think time is up. Thank you very much.